Good morning, students. Today we will do the second part of the topic LCM of exercise 2E of our chapter Factors and Multiples. Question number 16. For the pair of the numbers, we have to prove the property that product of two numbers is equal to their HCF and LCM. Now the numbers here are 87 and 145. So what we will do? First we will take out the prime factorization. We see that 87 is equal to 3 into 29 and 145 is equal to 5 into 29. So 29 is the common factor, so HCF is 29. And what will be the LCM? It will be the product of all the factors, so LCM is equal to 29 into 3 into 5, that is 435. Now we have to prove that HCF into LCM, that will be 29 into 435, that is 12,615, and product of the numbers, that is 87 into 145, is again 12,615. Hence it's proved that HCF into LCM is equal to product of the two numbers. Now question number 17 is the product of two numbers is 2160 and HCF is 12, and we have to find out their LCM. Of course we will be using the property that product of two numbers is equal to HCF into LCM. So please write it. What is the product? 2160 is equal to 12 into LCM. Now what will be the LCM? 12 into LCM. So 12 is coming to this side. So LCM will be 2160 divided by 12, which is equal to 180. So the LCM of two numbers is 180. So most of you are not showing the division or multiplication. Draw a line, write rough and show me the division or multiplication. Okay, it is very needful. Now the next question, question number 18 is the product of two numbers is 2560 and the LCM is 320. Find the HCF. Again we are using the property that product of the two numbers is equal to 2560. So LCM into HCF is equal to product of two numbers. So HCF will be 2560 divided by 320, which is equal to 8. And here also you have to show me the division while writing in the classwork copy. Next is question number 20. The HCF and LCM of two numbers are 131 and 8253 respectively. If one of the number is 917, find the other. Okay. So given HCF is 131, LCM is 8253, one of the number is 917. Again we are using the property that product of two numbers is equal to HCF into LCM. Now write it one by one. 917 into the second number is equal to 131 into 8253. So second number will be 131 into 8253 by 917. 8253 and 917 we can be deducted by 7. We will be getting 1179 and 131, and we can strike off 131 and 131, which is in the numerator and denominator. So after multiplying the second number is 1179. Now question number 22. Find the least number which when divided by 25, 40 and 60 leaves 9 as a remainder in each case. So here there are two parts. First we have to find the least number, and again it should be leaving 9 as a remainder. So let us remember LCM. What was it? The lowest number which is divisible by two or more numbers. So here first we have to calculate the LCM, and then we have to take care of the fact that it is leaving an remainder. So how we start? The least number exactly divided by 25, 40 and 60 is their LCM. So and the required number is leaving remainder 9. So it will be LCM plus 9. Now LCM of 25, 40 and 60 we have calculated it to be 600. So the required number is 600 plus 9, that is 609. Is it clear to you? Why we are taking out the LCM? We are taking out the LCM because it is the lowest number which should be divisible. And why we are adding 9? We are adding 9 because it is leaving a remainder 9 after dividing it. Okay. Now next is question number 23. Find the least number of 5 digits that is exactly divisible by 16, 18, 24 and 30. This is a very important question. Please understand it carefully. We have to take out the least 5 digit number, and again that should be divisible by these 4 numbers. So what is our least 5 digit number? Least 5 digit number we know is 10,000, and the least number exactly divisible by this 16, 18, 24 and 30, it should be its LCM. So first we have to take out the LCM, and the LCM is 720. Now we have to find whether the number is divisible or not. So here we divided 10,000 by 720 and we are getting a remainder 640. Now listen carefully. What is our remainder? Remainder is 640. That is the remainder. It should be divisible if the difference between this 720 and 640 was added to it, right? So the least 5 digit number that is exactly divisible by 720 is 10,000 plus the difference of 720 and 640, which is 80, and our answer is 10,080. Now next is question number 24. Find the greatest number of 5 digit exactly divisible by 9, 12, 15, 18 and 24. So it is the greatest number of 5 digits. So greatest 5 digit number is, we know that it is 99,999, and the least number exactly divisible by this 5 number should be its LCM. Here our LCM is 360. So by dividing 99,999 by 360, we get a remainder of 279. So the greatest 5 digit number will be, we will be subtracting this remainder from the dividend. Hence it is 99,720. You can ask me why we did separately in the last question, because it was asking the least number. If we had subtracted the remainder over there, we would have got a 4 digit number, but it was asking a 5 digit number. So that step was followed. But this is little bit different, and be careful. Okay, student, listen carefully. From question number 25, 26, 27, 28, here all the questions we have to calculate the LCM. They are asking the LCM. Read the questions carefully. If you have any difficulty, you will be asking me. Now come to question number 29. An electronic device makes a beep after every 15 minutes. So it is making a sound after every 50 minutes. Another device makes a beep after every 20 minutes. Now they beep together at 6 a.m. and what time will they next beep together? So the LCM of the time intervals of the beep will give the time when both the electronic devices will beep together. So we have to calculate the LCM of 15 minutes and 20 minutes, and the LCM is 60 minutes, which is equal to 1 hour. So if they beeped at 6 a.m., the next beep will be 1 hour after 6 a.m., that is 7 a.m. Okay, is it clear? Now the next question, question number 30 is, the circumference of the 4 wheels are 50 cm, 60 cm, 75 cm and 100 cm. They start moving simultaneously. What least distance should they cover so that each wheel makes a complete number of revolutions? Now distance covered by a wheel in one complete revolution is equal to circumference of the wheel. So the least distance wheel should cover so that the wheels make a complete revolution is equal to LCM of the circumferences of the wheels. So we take out the LCM of 50 cm, 60 cm, 75 cm and 100 cm, and what we get, it is 5 to the power 2 into 2 to the power 2 into 3, that is 300 cm, that is equal to 3 meter. So each wheel will make a complete revolution after traveling 3 meter. Is it clear to you? Exercise 2F. Now in our next question, question number 13, we have to take out the HCF of 144, 180 and 192. So here we are using the division method. You can use prime factorization method also. So in division method, what we are doing? We are dividing the greatest number 192 by 180 and we are getting 12 as our HCF. Then again 12 will divide 144. and since the remainder is 0, the divisor becomes our HCF. So HCF of 144, 180 and 192 is 12. I hope it is clear to you. Okay. Now comes the next question, question number 15, where we have to convert this fraction 289 by 391 into the lowest term. So what we will do? First we will take out the HCF of 289 and 391. Here again I am using the division method. So after dividing, we see that HCF is 17. Now we are dividing both the numerator and the denominator by 17 and we are getting 17 by 23. So 17 by 23 is the lowest term. I hope it is clear to you. Now our next question, question number 16 is we have to find the greatest number which divides 134 and 167 leaving a remainder 2. That means they are asking the HCF of 134 minus 2 and 167 minus 2. Why? Because it is leaving a remainder. So HCF of 132 and 165 we are using the division method and we are getting 33 as the HCF. So the required number is 33. Okay, students, these are very important questions. So if you have any doubt in understanding them, please message me. Now next question is question number 19, where we have to take out the smallest number which when diminished by 3, diminished means subtracted, okay, and divisible by 14, 28, 36 and 45. Take care of the question. What it is asking? The smallest number. That means lowest common multiple. We have to take out the LCM. So LCM of 14, 28, 36 and 45. What we get? We get 1260. So what is our number? Our number will be LCM plus 3. Why? Because it was diminished by 3. So we are adding that. And the answer is 1263. The next question is question number 23, where LCM, HCF and one number is given. We have to calculate the other number. So here we will be using the property of HCF which we have studied. What is the property? Property is HCF into LCM is equal to product of two numbers. Now what is the product of two number is equal to HCF into LCM? That is 145 into 2175. And therefore the other number will be 3,15,375 divided by 725 and we are getting the other number as 435. Right. This is question number 25, where it is told that the bells ring together first time after 9 minutes, 12 minutes and 15 minutes respectively. So when it will be again tolling together, what we will do? We will take out the LCM of 9 minutes, 12 minutes and 15 minutes. And what we are getting? We are getting 180 minutes. So 180 minutes on converting becomes 3 hours. So the bell will again ring together after 3 hours. Okay. So students, please complete the remaining part of exercise 2E and 2F. And you can leave the repeated questions. Okay. So thank you.